I'll just make sure the audio is going through and I'll get started in a second. In another interview, I spilled chai on my laptop when going live. I've
Ouch.
done, I've done all the possible mistakes at this point.
And did it survive?
Yeah, like I was able to make through the live stream, and then I like put it out in the sun for like a day, and it's still working. So
Oh,
don't tell
lucky,
IT.
lucky, lucky.
Don't tell IT. Okay, we're live. I can hear myself. I'll close that tab. Hey everyone, thanks for watching the live stream if you're watching live. Thanks for watching the recap if you're watching the recap. I'm super excited to host one of the best Kagglers in the world. That's a statement. He's ranked number 5 in competitions. If you go to the rankings, you don't have to scroll much. And I'm sure he's moving up because he keeps winning more and more medals. I'll share some stats about Dr. Pascal Pfeiffer, also famously known as ILU on Kaggle, with a graph in his Kaggle profile. Pascal has won 20 gold medals in the last 2 years. And out of these, 4 wins, that's number one, team wins in 2 years. 18 of his gold medals, counting the wins, were in the last 2 years. So I'm excited to find out what water he drinks, what he adds to his chai, and like his journey, including his recent solutions. Pascal, thanks for accepting my request.
Thanks for inviting me. Very happy to be here, Sanyam.
So what water do you drink? What do you add in your chai? What's the reason behind all this massive success?
Well, I think it was mainly joining Kaggle and getting that grasp from Kaggle, learning like lots and lots of stuff. There is new things coming out every day, basically, and you really need to filter what is important and what is not important. So that was a very, very steep learning curve for me when joining Kaggle. I think I joined like 4 years ago in 2019, and since then I was trying to constantly improve on everything that I do there, and also in my professional life. So yeah, just getting to know the new flavors of the month and trying to filter out what is important from that. I think this is a very, very uh, yeah, very, very important point to being successful.
I thought you'd mention like a secret chai or something like that, and everyone will rush to buy that after this live.
I'm sorry, I didn't find it yet.
You
The
know,
secret.
Philip told me in secret that he has like a special chai ingredient, and
Yeah,
he like drinks chai in secret.
I'm pretty certain he does have some kind of secret.
Jokes aside, I'll come back to Kaggle and come back to your Kaggle journey. But you started your journey as an electrical engineer, and then you went on to achieve a PhD in it. Would you say building electrical circuits is harder, or training machine learning models is harder, or like are there any analogies for you? Because you have a lot of physicist Kagglers. I think Jeepa is one of the electrical ones, but I don't know many others.
Right. Yeah, I think a lot comes down to being self-taught in this kind. So during my studies, a lot of what I did was self-taught, and the same thing carries over to Kaggle and machine learning. So yeah, as I said earlier, filtering out the unimportant stuff and learning the new important stuff is always something that helped me throughout my career, and throughout my studies, my PhDs. And yeah, I don't think you can say if either of those is harder. Like saying ML, machine learning, is harder than electrical engineering, or vice versa. It's super difficult to say. I mean, in every field, you have these super high ranks or super knowledgeable people, and you barely can reach them in any case. Yeah, when it comes to the top of any field, and this is not just including these two fields, um, everything becomes difficult and everything becomes super competitive. So yeah, I can't really say which one is harder. Though I do like the machine learning part, and this is exactly why I switched over from electrical engineering. But I certainly have these things that I learned in electrical engineering, like especially on signal processing, filtering, all of these things that are still super helpful in machine learning, especially when it comes to data pre-processing, any kind of cleaning, finding out some biases in the data and all of this. So this is all parts that I already learned in my studies and that could be directly applied to machine learning.
Makes sense. I thought there was like some secret recipe again in electrical engineering, maybe.
I'm sorry, there are no secrets, I guess.
I'll make an effort to find one today. That's my agenda.
Okay.
So how did you get addicted to Kaggling and the field of machine learning? You are one of the top ranked competitors, and I'm sure there's a lot of effort that goes inside of it. How did you discover the field, and how did you get addicted to it?
Yeah, addiction is the right word, I guess. So yeah, when I joined, it was basically just to learn machine learning, I would say. So I came from knowing nothing about machine learning. I bought one book and I read it and thought to myself, okay, let's just try this and code a few things and yeah, try to make sense of it. And it didn't feel like being enough for me, as these are just toy problems and you can overfit them crazily, and you can always peek at the test data. It's always a mess in these kind of things. So I thought, why not learn it in the actual field where you have no idea what the real test data looks like. I mean, you did have an idea what the test data looked like back then, because they didn't have code competitions. But you didn't know anything about the labels or the label distribution or anything about this, so it was kind of still hidden in this manner. And this taught a lot for machine learning to me, as yeah, specifically on the very first on the very first competition that I joined, there was a super heavy bias in the data and the test data. So just adding a super simple slope it was a time series problem. So just adding a slope to the predictions in the end would already give you, I think, even a win in this competition. So this is something that I really learned then when
Was
joining
it this one?
Kaggle. No. Okay, maybe I joined this one too, but I didn't really participate. I think I meant the Microsoft.
Malware?
Say again?
I think it was the
Malware.
malware.
Yeah, malware. Microsoft malware. So yeah, this was kind of a crazy competition back then. Yeah, time series, tabular back then, not a huge amount of data. So it was, yeah, like nothing you would expect nowadays, probably. Because you always have much more data. But yeah, it taught a lot about pre-processing data, making sense of it. Yeah, some feature engineering was very important back then, as transformers were not a thing. So yeah.
So, what were the initial days like for you while you started Kaggling and while you were learning? How did you go about it after purchasing the book and finding Kaggle? How did you like make a conscious effort to improve your knowledge?
Yeah, reading solutions was like one of the main things I took from Kaggle, and I'm super grateful for this, for everyone sharing their solutions on Kaggle, and I try my best to also share mine and our solutions on Kaggle after the competitions finish. So getting these ideas and these even more importantly, the thought process behind the solutions was super helpful when getting started, and it's still super helpful. So after a competition ends, I'm always going through all the write ups, even in the competitions that I didn't join. and try to understand what was the reasoning behind some ideas that people took, and the approaches that people took. And it's sometimes very, very interesting to see multiple approaches being similar, successful, and sometimes there is just one single approach being successful. So this is very, very very interesting to see after each competition. And it's like the single most important thing on Kaggle, having these sharing process after a competition ends, about all the top solutions.
I think there are levels to it. Like when you start out, you're just like amazed by how good the solutions are, and then you like start to understand them, and then you start finding gaps in them, and then you are able to know what the gaps are. So did you like go through this process as well? Maybe it's just me, but I'm like at the point where I can know, okay, like they haven't told this recipe. So would you like re-implement the solutions to understand them, or would you like go back and make past submissions?
You mean using different solutions and trying those really quickly, or and seeing the gaps between the different approaches? Or what do you mean with gaps
I,
here? Sorry.
I'm sorry. I'm just curious. Like many times, top winners don't say their exact solutions, and they like leave out main bits. So, like, would you go back and learn those by like re-implementing them, or did you spend any time submitting to older competitions?
I see. I see. No, I haven't. I haven't done this. I think I did it in the very first competition. So right, yeah, in the malware competition, I really did re-implement the first place solution. But after that, yeah, I've I didn't really spend too much effort in doing this. But I definitely looked at the older solutions and tried to implement the same things for the next competition. So every time that I thought, okay, this makes sense to try in another competition that I'm currently working on, I would go ahead and re-implement these kind of things and try to make them work. But
Makes
then,
sense.
as always in machine learning, you have these sometimes stuff works in one competition on one kind of data, and it doesn't work at all on another kind of data. So having a huge amount of ideas and a huge amount of resources to look at is always helpful.
Do you find your intuition or gut knowledge to be wrong still after like being so experienced, or now do you have
For sure.
like? I thought you would have it figured out at this point.
Not at all. I mean, sometimes I'm very convinced that something must work in this case, and it doesn't work at all. And the same thing applies also in the other direction. So if I'm super convinced that it can't work, it shouldn't work in this case, I would mostly still try it out and see that it sticks to to your validation, and yeah, you get convinced then.
So maybe it's just me, but like I would just give up very easily. What's the secret to not giving up when like ideas stop working?
Well, giving up is is one thing that you would maybe do when you're convinced that the data it doesn't have any signal or something like this. There have been some competitions where you really think there is no signal in the data at all. I think even the one of the more recent ones with the blood cells. I think it had very, very little signal, and I shortly tried it out locally. Got a CV score which was barely anything above randomness. So this is something that I gave up on. I just said to myself, this is not worth it, and it should be random noise on the leaderboard after this, or on private leaderboard. But apparently, people found something, and I'm while it was still very random, I think the top competitors still found a little bit of signal in there. But it's tough to judge if there is any gain out of this solution with regard to productionizing or something like this. So I'm not super convinced that it's worth the effort spending there in these kind of competitions. And I try to avoid joining them all together, because I easily get very attached to competitions, which yeah, I can't really stop submitting and trying to improve on on these competitions once I joined them. So this is something, yeah, that it's maybe it can be positive and negative at some at some points.
But you somehow always find to manage the secrets and the secret sources. So it always most of the times it works out. It looks like from the outside. Um, Sorry.
It did work quite well. Yeah.
So speaking of that, I also want to learn about your solutions, and I'm sure everyone is watching this to learn about Team Hydrogen. But I'm becoming a YouTuber now, so I'm like trying to start a controversy. How's Philip at work versus Philip at Kaggle? Which Philip is like cooler, or Yahoo for that matter?
But he's the same guy. No, I think
I'm just
we work
starting
with
with
a lot of
controversy.
Kagglers at H2O. So it's a very similar workplace to teaming up with Kagglers just on Kaggle. It's not much different, to be honest. And it makes it also very easy on that professional side to work along with all these great Kagglers, great Grandmasters. So it makes it very easy to discuss new ideas, to have a very reasonable discussion as well. So everyone is very humble and yeah, trying to yeah, ingest all these new ideas that are really coming up every day. So we are all very open to new ideas, to new thought processes, and all of this. So yeah, it's a great experience with regard to Kaggle and with regard to work.
Yeah, I also wanted to point out that your expertise also makes it into different projects, and I've shown Hydrogen Torch many times to the community. I'm sure it comes directly from your learnings from Kaggle and, of course, outside learning as well. And I've also built Label Genie, which is I was just testing this earlier. We were talking about it. It's one of the best annotation tools out there. So all of your knowledge also bleeds into all of these tools on the App Store.
Exactly. Yeah, I think while doing Kaggle, you learn all these new ideas and especially best practices when it comes to, for example, validation on your data. And we kind of found out what works best and what doesn't work so well. And we kind of made this a no code platform, so you don't need to dig in all the Python code to train a model for some of the easier problem types, such as yeah, classification, regression, simple NER, everything that you can know, that you can think of right out of the box, and you can easily just choose some hyperparameters and train some models for this. So this comes directly from yeah, Kaggle experience, and everything that we are applying there also was used in creating this app.
And I'm just screen sharing and pointing to all the problem types that are supported. And as you can see, it's an extensive list. I had posted a video earlier to the channel where I tried to showcase Philips solution, and I ran feedback competitions dataset through Hydrogen Torch with almost the default settings, and it got to a score of silver. I think on CV, so that speaks to the tool in just under 10
Exactly.
minutes.
And
I
this is
think.
just a single model then. We are not talking about ensembles, which usually makes in NLP at least makes a huge difference. So just blending even multiple seeds together already makes a huge difference there. So yeah, I'm pretty convinced that these kind of approaches make a lot of sense to share.
And all of them are already built into different settings that I don't think many people even realize, or like after you've run into so many errors or like so many common mistakes, or you end up leaking through your phones, or such simple steps that you feels like rubbing your toe against your bed's post. You just You just don't have to worry about all of this through using such tools.
Yeah, I mean, you still need to worry a bit about data pre-processing, and this is always the case. And we even see that within Kaggle competitions, that there are leaks within the competitions with regard to to data pre-processing. So yeah, having these good splits always is a very important step towards good validation.
Yeah, I I suck at both, so I can't speak to any of those. But if the audience is interested in learning more about these, it's linked right under the like button, so you're welcome to check that out. And I'd also love to now transition to talking about your recent. It was supposed to be 3 wins. Now it's four. By the time someone's watching this, it will be 5 or 6 or 7. Who knows? But I'll start by talking about the NFL competition. I'll start with a silly question, which my understanding is people in Europe usually don't watch as much NFL. But your teams have been dominating the NFL competitions for a while. So, uh, do you like secretly watch NFL when everyone is watching Liverpool matches, or what's the secret there?
I personally like watching Super Bowl, so this is something I do every year. But other than that, I rarely watch any football at all. So this is something that taught me at least some of the rules to get a better understanding there. So I'm not a complete novice, but still all of the um, more hidden rules. I don't know anything about them. But yeah, I think the NFL competitions always had been super great with regard to the hosts and the pre-processing, all everything that was around the competition setup. So hosts were always very quick in responding to questions from the Kaggle community, and they always had great metrics. They had a super stable setup with regard to validation, test data. They were always very clear about their setup, about their test setup. So there was no unexpected shakeup at some point. So this makes it easy to join these kinds of competitions, and you feel very confident about joining them and having a good CV. Without getting any unexpected results on the leaderboard then. So this is something that made us join these competitions. And obviously now when you compete in these follow-up competitions, you kind of get an idea of how the data is structured, as they are not changing too much from one year to another. But obviously the target or the task itself is completely different. So you can't really reuse anything from the solutions. And even with this year's competition, you had the baseline for the helmet detection from last year's first place solution, which was insanely strong, and there was no way of making better predictions for this in this year's competitions, given the 9 hours runtime that you had for your final submission. So this was really something that I find very interesting here. It gives maybe the people that joined the last competitions a slight edge, but not too much to be really significant in these cases. So yeah, as I said, it was a completely different task this time, and you were just reusing the predictions from last year. And maybe if you competed in last year's competitions, in the last year competition, you would know the problems that people were facing there, and you maybe got an idea of in which situations the predictions are less successful than in others, and that gave a slight edge maybe, but nothing serious, I would say.
It's also cool to see your journey from teaming up with Rob and then still doing well on competitions, and Rob going on the other side as a host. And I read in your solution post as well, you really enjoyed how interactive he was. And also I want to plug his channel, so to everyone watching, you should definitely see his channel. It's one of the best ones in machine learning. But it's also cool to see your journey to going from 2 years ago to today, still winning the competition, still winning gold medals there.
I think it was second place, right? Even back then. So we kind of always win second place there.
So will you like stop competing in NFL after you win it, or will you keep competing? Hypothetically.
Probably not. As long as they are coming up with new, very interesting competitions, I'll probably still join them. I don't like joining repetitive competitions, so where you just can't learn anything new, because it's pretty clear that the last year's solution will win with just some
Mhm.
slight improvements, maybe. Um, this is not something that I like joining a lot, because it's just very heavy on iterative improvements on your solution, but it doesn't teach you too much new stuff. So I really like to join new competitions in every field. You see that's computer vision, NLP. I started also out with Tabula a bit in the beginning. So it's pretty diverse in the competitions that I take, and they don't have too much overlap, I would say. So yeah, this is always something that I'm looking for when joining new competitions. Hope they are new, and that they teach me something in the journey of trying them, of competing in
It's
them.
it's really one common thing about top Kagglers that they don't stick to one domain of just computer vision, just NLP, just tabular. They're like always doing really well across multiple competitions, and it's
Yeah, I
always
mean they
like
exactly. I
sorry.
mean they nowadays even share the same architecture in some places. So you had this idea of transformer models starting out for NLP tasks, and nowadays they even get applied to computer vision tasks. So there is quite an overlap in understanding as well. Obviously, the augmentation techniques are completely different, and I'm still struggling to find anything reasonable for NLP, to be honest. So if you have some, please send me them.
you
But yeah,
you don't find back translation and the usual twisting of words where they like make change some spellings and do some like very vanilla stuff. You don't find that effective.
I haven't found it to be super effective. Maybe sometimes a little bit, but in most cases that I tried it, it was not even better, maybe sometimes even worse. I don't know. I didn't find a single application where it was clearly better, let's say, than just training on raw data, on raw text data. But it's also something probably about the pre-training nowadays. So
Hmm.
these language models are pre-trained on a super large corpus. So they are multilingual, even if they are not supposed to be multilingual. So yeah, I think it's just not much extra signal that you're giving there, and it then comes down to probably adding more iterations or something like this. It's then again tuning some hyperparameters, but getting some real extra signal out of back translation, I had my problems. I even think that it kills some signal in your original data.
I'm just waiting for when stable diffusion is being applied to tabular and NLP. So you said common backbones. I'm just waiting for that day.
Right. Yeah, I think with ChatGPT 4 now being released, a lot will also drift towards this zero shot learning, zero shot predictions, even. So people don't even need to train on their data, because yeah, a huge model was already trained on almost the entire internet, and then you yeah. it,
Yeah.
it will
So
still have its domains where a single model which was fine-tuned on this exact data is still much better. But then you have this more general problems where these kind of zero shot models are still are already shining, and they already are yeah, almost on par with the fine-tuned trained models.
hmm. Yeah, I don't want to go into a generative AI discussion because that usually takes hours and it's very polarized. So coming back to NFL, I'll start by going through the competition and trying to explain to the audience what the problem statement was. So I'll try to explain it, and if I mess it up, please interrupt me. But from what I understood, this competition has been going on for a while. And in one of the discussions, Rob said that the name is just conventional. So first and future doesn't hold any meaning now. It's just like what they went with and kept going on with. But the latter part is true. So you're trying to detect player contacts. And earlier you used to just detect where the helmets were colliding, but at this point you're supposed to detect which of the players are colliding. Are their helmets colliding? And also, if they're falling to the ground, you have to also detect that impact. And these are through video clips, which are from very non-ideal. I would say from my perspective, very non-ideal camera points, because in a game I assume it's like very zoomed in, very perfect, but these are like very sideline views or the other endpoint views. Is this a correct representation?
Yes, yes. I mean, with one small exception, maybe. So the ground contact was not only counted for falling to the ground, but also when people were kneeling on the ground, or yeah, just while standing up or something like this. So everything that was in contact with the ground that wasn't a foot was counted as ground contact, as far as I can tell. There was some super small changes to this where it was a bit inconsistent, but this was also raised in the discussions. So as always, if you have data, there are some slight inconsistencies and label noise, which you just can't do anything about it.
And these were through video clips that were spread out through different parts of the play. And one more challenge, if I may, of the challenging bit of the competition was you were provided tracking data, but that was at 10 hertz, whereas the videos were on 60 hertz. So like this inconsistent, or you had to figure out how to align both of these. And from what I read, the tracking would also start a few seconds after the play would start in some settings. So that was also an added challenge, as I understand.
Yeah, the hosts already did a super great job here, because all of this data processing, like aligning the tracking data with the video data, was already done for us. We even had a starting baseline notebook based on tabular features, which was already very yeah, competitive. Or it had a good score here, as you can see, or an okayish score, by just making use of some very basic features. But it already gave a lot of helper functions that were reusable for any kind of approach. So this is always super helpful for Kagglers to not need to re-engineer everything. And it's also something that they added now with the Python scoring metrics. So you don't need to re-implement the whole metric just by reading the evaluation page. So yeah, I like when the hosts make it easier on the data preparation side and on the evaluation side, that you can really just dig into the data and yeah, start digging into the data and start training models, and not mess too much with all of the work that
License
they
discussions.
already did.
I'm starting controversies after controversies today. I'll not do any more jokes after this. I was making a joke about licenses and sometimes the unclarities that remains with different competitions, but that's another discussion. Um, Coming to NFL again, so I think that's a good overview. And you were supposed to predict these on 29 unseen plays, and the lengths of the videos are somewhat similar to the training data. So that was the main challenge here.
Exactly. So we had a lot of training data in this competition, which maybe was not ideal, because you had basically, if you did a fivefold stratified k-fold, a group k-fold on the game key, which was basically resembling the split between training data and test data, you would have even more plays in that one validation fold than you would have in the entire test data set, or in the public leaderboard or in the private leaderboard, splitted. So this was maybe a bit annoying that you had less randomness locally than you would have on the on the leaderboard. But still, it's always good to have a lot of training data, and I think that's what they were most interested about. So to get the best model that is possible out there. And then obviously you also need to think about the runtime. So if you want to squeeze in everything into these 9 hours of GPU runtime, you can't add too many plays into this inference. So I guess it made sense in this sense. Basically we went ahead as always. We thought about a good split here. You have it open. Very nice. We thought about a good validation split, and just went with a stratified group K fold, as I said, on the game key, which proved to be very, very stable with regard to CV and leaderboard. And then never changed this validation setup at all. And then we started out, because we just finished the DFL competition, which we were quite successful in, with a very good with a very good setup and a very good model here. So we already had an idea of what to try here in this competition, as it was similar. I mean, it was soccer versus football in this case, so same kind of data, just something else to predict. And maybe with some extra data, as you had some helmet boxes here, which you didn't have back then in DFL. But we tried to take that model architecture that was already successful in the last competition and tuned it then to this competition. And even with a very basic setup, it already got quite good results. So what we did in the first iteration was that we just cropped the region around the contact, and then fed this image into our backbone, which is a combination of 2D and 3D convolutions. So it's using an efficient net v2 backbone, where we keep everything the same. So it has 2D convolutions in the first layers, but then in the last layers we switch to 3D convolutions and add in multiple of the previous states. So if you run through the backbone, you will not only get the single frame in the middle, but you would also concatenate the other frames around it by applying some step here, and feed it then through the 3D convolutions. Obviously, you need to split your backbone in this case, and reshape your vectors, your tensors. So you now have your batch size is no longer the batch size really, but it also includes the multiple steps. But then in the end, you have a single prediction and a single end-to-end solution, which makes this very elegant, I think. So you really just have a single model with multiple inputs, in this case, multiple time steps, and then feed that forward through the model, get a single prediction without trying some multi-stage approaches or something like this. It's always something that we try in the first place, having an end-to-end solution, because it doesn't induce human bias where you would filter something or something. Yeah, I mean, we need to be real here. Anything that you do manually will induce some kind of human bias. So giving this all to the models sounds better always in the first place. Obviously, sometimes the models are just can't learn anything. Then you need to guide it a little bit, and that's what we did then after trying this very first stage approach. So just cropping the helmet around, or just cropping the region around the contact, or the two players, or the contact to ground, that possible contact to ground. We then added multiple channels to this. So we, yeah, in this case, we encoded features from the baseline of the last year's solution, where it includes the position of the helmets, and also the position of the helmets of the other players. So in this case, if there are like 5 players in the cutout, in the first iteration, our model wouldn't know which of these two players should it focus on. So obviously, you need to guide it through this information, and that's why it was so important to add this feature. And it obviously it improved our CV score a lot by just adding this very, very basic feature. And then we always had a second stage model still, just to find more features, as it was a lot of tabular features which you could make use of. So we always ran a second stage model on top and tried to find some features that were helpful to get some boost there. And at some point, we found that this feature of 2 players belonging to the same team was super, super helpful. And even by looking at the target distribution, it makes sense, because there were lots more contacts between non-same team than for same team players. So we just thought, okay, let's add it to the channels as well, and we did so. And it also helped to improve the first stage model a lot. So that was kind of our second channel that we added there. And then we just went through and added more and more information to these channels. So try to encode the distance between the players. Also tried with a lot more features, even the distance traveled by one player at a given time, or speed, or anything like this. But basically, it came down to these five channels, or 5 features that we encoded there. And this was then our final solution, where we encoded this. And it was very, very helpful, as the model could also learn about the spatial resolution here. So it makes sense to encode the features directly into the channels, as the convolutions would then go over this exact spot, and it would directly do the alignment to the players that it belongs to. Other than having to learn this from a late fusion, for example. And this is also something that we learned throughout the competition. So we also tried this, obviously, to have the late fusion, so embedding, so getting the last embedding out of the images. And then concatenating some extra features to that by adding some features such as same team, position, distance traveled, etc. But it was always much worse. So not even in the range of this early fusion. So it makes sense to give the model all information as early as possible. And this is also something that I believe is very very important for future competitions. So not making the assumption that these things are independent from each other, but just trying to make work of the current backbones, and trying to encode information early on.
Thanks for that overview. I have a bunch of silly questions, if I may, from different parts. So you mentioned that this was an end-to-end backbone, and you had just changed the last few layers to 3D convolutions. Were there like any other tricks to help this converge? Because 3D cons, they sometimes, in my experience, you need to train them for longer, or you have to add some other tricks to stabilize training. Did you experience that?
Actually, the trained quite stable, I would say. So yeah, what we did in DFL was stacking multiple time frames also in the 2D domain, but it seemed to not help here at all. So yeah, as you can see here, we stacked images like here 14, 15, 16. These are the frames in this case, and fed it already through the 2D layer. But in our case here in this competition in NFL, that didn't really help.
Hmm.
So just feeding through a single frame through this 2D convolution and then only doing the stacking within the 3D convolutions was always better for some reason. But yeah, we didn't have many issues here. What we always try is um, to use differential learning rates. So having a higher learning rate, for example, for the new layers on top, than having for the layers on the bottom. But in this case, I think it wasn't really needed. And
Hmm.
what we did for the 3D layers was even to use this for the 3D convolutions was to not just replace them, but to also use the weights of the 2D convolutions and to stack them. So if you have now a 3D convolution over kernel size 3 in the z direction, you would add the weights 3 times and stack it together.
Okay.
So you have a much better initialization in this sense. I think this may be one of the reasons that it doesn't work sometimes. If you just replace it for a 3D layer and you would initialize it with raw weights, they are not pre-trained at all. So just random weights. I
Hmm.
guess that would be a risk, and that would not work well, and maybe doesn't converge at all. I don't know.
Yeah, I just replace it with 3D and then I get batch size errors and then I give up. So that's
Yeah,
why
okay, that's
there's
probably
progress.
then the reason. Because if you don't initialize it with yeah, with the old weights, it could be tricky, especially if you do not just do a single a 3D convolution but multiple ones. It could get very very tricky.
Makes sense. Thanks for clarifying that. Another question. So you mentioned you also were tracking that cropping around helmets was quite helpful later on. Team Hydrogen usually, not in this case, but most of the times joins late and you always make incredible progress. So do you have like a solid framework to track these experiments, or what's your strategy there? Because I'm sure you're trying multiple ideas together. So how are you like going about that? How are you thinking of ideas, tracking all of that? I'm just curious about that bit.
Yeah, most importantly, having a good validation setup early on is super helpful, as it makes it much easier to track the improvement and to really track what is sticking to validation and what not. So if you would change the folds throughout the competition a lot, or just do random folding, I think it's super tough. But in this case, yeah, it was a very good validation setup from beginning on, so that made it easy to track. And then, as we are working in a team, it's also very helpful to share the results and all of the experiments that you're running. Obviously, you could do that in a spreadsheet or something, but it's getting very very hard to track. So we make use of Neptune, for example, as a tracking tool, and it's one thing that I can only stress so much. So having some kind of tracking tool which everyone can access to, and everyone can check what hyperparameters are your teammates using right now, what are they trying, and how are they improving their score, is always super super helpful. And it always gives you a discussion base to, yeah, to get new ideas, to discuss new ideas, all of this.
This is my SOTA way of tracking experiments for stable diffusion competition.
Yeah, I mean, you obviously do this on your desk too. I do this all the time on my desk, even to keep track of new ideas early. I mean, before getting to sleep or something, so I don't lose them for the next day. But yeah, it makes sense to share these results and to track. We usually have about 1,000 experiments or so after a competition combined. Sometimes it even goes higher depending on the runtime, and you would easily lose track of this. So it only makes sense to get a good to have a good tracking there, other than having a spreadsheet.
Thanks for that answer.
What we also do is having we keep track of the leaderboard scores with regard to validation. Because it gives you a much better view of the estimated scores on let's say private leaderboard. If you have a large distribution, there are a super large gaps, and it's not really correlating. And this was something that we faced in RSNA, and which almost made us quit this competition because it was very random, let's say. And obviously, apparently, it was always coming down to just a single or two hits more that you found in the test set, and that already boosted your score by at least 1 digit or 2 digits maybe. Yeah, and this made it very hard to track. And yeah, it's these kinds of experiments that kind of demotivate then a little bit, I would say. If you see some improvement on CV, or you improve your rock AUG a lot, and it doesn't stick at all to F1 score because it's thresholded and it doesn't care about anything about the low priorities, this is a bit demotivating then.
Shout out to Nishchay. I know he would relate to this because I was talking to him when he was doing RSNA and he mentioned this. Nishchay at that time was an intern with us. So coming to your solution, you mentioned the stage 1 and you shared the sources there. Anything you want to highlight from stage 2 of your modeling?
Yeah, we had. Yeah, as I said, I mean, our stage 1 model was basically already on par with the stage 2 model. In the end, at least, we always had the stage 2 model running after it, just to see which features are important, and then we try to backport them to stage 1. But still, in the end, we also made use of the stage 2 model as it. Yeah, apparently it added a little bit more accuracy for. I don't know why. I mean, we have some features left here, which are, for example, the step percentage, which we used then in the LGB solely and didn't use in the first stage at all. So it probably made sense to stack it together. But yeah, as I said, the one stage approach already has a super high score already without any second stage model.
Makes sense. I also learned that it's a good idea to backport these features. That's something that I didn't think of earlier and I haven't heard of earlier. So thanks for sharing that. Anything else you want to highlight from your solution before we move on?
Probably not. If you don't have any specific questions.
I do not. This was a very clear explanation, and for a change, I was able to understand all of it. So thanks for that. I'll again point everyone to the leaderboard, and you don't have to scroll much. Just click on second place solution. You can find that, or in the description as well, you can find the links to it. I also want to cover briefly RSNA, where your team had finished 11th. I know you haven't shared your solution, so I'll keep it quite brief. I'm just curious, what was your secret to surviving the shakeup there, and if you could share any brief overview of your approaches there.
Yeah, surviving the shakeup wasn't really possible, as you can see on the leaderboard. I mean, yeah, it was quite shaky in the end, and this is exactly what we expected from tracking these leaderboard to CV correlations. So not all of the improvements were sticking to leaderboard, and it made us almost quit this competition a few times, but in the end we decided to just sub a good cross validation score, which also had a good rock AUG, and we tried to track a few proxy metrics as well, and also tracked the metric for site 1 and site 2 individually, so that we were pretty confident that it should be a somewhat stable, a somewhat robust solution, and just went with this. We didn't have much hopes in the end, so we're happy that we didn't drop too much. But yeah, that's how it is. Basically, our solution wasn't much different from other solutions. So if you read, for example, the fourth place solution, they also made use of this. We used the two views that were available, and other than the fourth place, we just concatenated the two views of one side, and stitched these images together. Again, early fusion of input, and trained then a binary classification model. We tried a lot with augmentations and getting rid of bias in data. But as usual in these medical image competitions, a lot of bias is also present in the test data, and apparently it didn't help at all. So just keeping all the bias and predicting with the same was always better on validation and on test data. So we didn't really bother to add much augmentation, other than mix-up, which kind of always helps, apparently. But yeah, this is basically our solution. So we concatenated the two views and trained a binary classifier. We obviously tried also a lot of other approaches, also trying to add the other view, the other side to the training, but that didn't help at all, and also made the images a lot larger, which they already had been. So scaling up this resolution was no option in the end, as you would run out of VRAM at some point. So yeah, this kind of came down to the solution. Pre-training on external data was helpful a little bit, not too much. And then fine-tuning on the competition data. But yeah, it all didn't make too much of a difference, and it was super shaky, as I said. Sometimes you could get, with almost the same model, just changing hyperparameters by a tiny bit, you could boost your score for site 1 by 10 points or something, and it was crazy. If it does so much on F1 score, and your rock AUG doesn't change much, it's always an issue with these thresholded competitions. And you could even see it on the probability distribution. So if you plot your all your validation probabilities and versus their labels, you would get quite a few very, very distinct features, or quite a few samples that were on very high probabilities. So the model is pretty confident that this is a cancer in this case, and these were almost always correct. But then you always also had a large tail to the lower end, where you would almost get zero probabilities for cancer types. And this is mainly, I think, the reason for the dataset sampling, because the dataset itself was labeled by posterior information. So yeah, there was sometimes even a biopsy after this, and they found cancer in the breast. So then they went back and labeled the images as cancer positive. But the doctors didn't even know that there was cancer by judging from the images. So this was nothing that a doctor could even see in the images. And most likely, I mean, it's the point of these competitions that you would find something that the doctors can't see. But yeah, in this case, maybe it was just too much of a stress, and the models just didn't learn anything new that the doctors couldn't see either. But yeah, that's just this part. And yeah, it was also something that helped in the competition. So there was this label with is true negative, and we just excluded these parts from training, and it helped a lot. It stabilized the training also a lot, which makes sense. I mean, these are just samples that you can't possibly detect, probably. Exactly. Yeah.
It was still cool to see that everyone had some shakeup in this competition, but still, Team Hydrogens wasn't as shaky as compared to some of the other teams, if I may. So I was curious to learn about your solutions still. Um, I've discussed all of the solutions I wanted to learn from you. So thanks for sharing that. And I'll also point folks to your learning equality team solution. So if I'll share my screen again and point everyone to the fourth place solution for this competition that ended today. So if you're watching it live,
Just
as
posted
you
3 hours ago.
yes, as you'd expect, you don't have to scroll on the leaderboard to find them. But you can also read this. I wanted to discuss it as well, but then it would be a 5 hour interview, and Pascal would never talk to me again. So I'm pointing you to this solution instead. Um, I'll start wrapping up by asking some general questions, which I always do. So I'm really curious, how do you as a part of Team Hydrogen, or also as an individual, balance everything among different competitions? Because at this point in time, you're competing on 3 competitions. You're also working on Hydrogen Torch and Label Genie at work, among other things as well that I don't think I'm allowed to discuss. So how do you balance your time? How do you what water do you drink that allows you to do all of that in parallel?
First of all, I would like to do a big shout out to my teammates. So not only Psy and Johan in this case for Team Hydrogen, but everyone else that I was teaming up with. So I really like to team up in Kaggle, and it also helps me a lot to stay focused there, to spend time and to not slack around, and keep to lose the focus. So this is definitely something. Teaming up, discussing ideas, keeping track of every day's progress. If you can't progress one day, maybe some of your teammates does, and it will keep you motivated throughout the competition. This is always something that keeps me driving there. Yeah, and other than that, I mean, we all have all have different responsibilities, and keep trying to juggle all of them. So I don't think that I'm much different there than anyone else.
Um, I'd still try to dig into that, but I'm just curious. You're one of the most successful Kagglers, if I may, in 3 years of competing, 3.5 years of competing, you've climbed to world's top ranks. What do you credit your success to? I'm sure there's a lot of hard work, there's a lot of brains going into it. What's the secret to your success, or what do you credit it to?
I would say don't take the current state for being the best state. Just always look out for better solutions is the most critical part at being at staying competitive. If you would take the state of 2 years ago and you would try to win a competition with this today, you would definitely fail, or not even reach some bronze medal ranks. So this is definitely something that is that is needed to be successful. Always be open for new ideas. Always discuss new stuff that comes around the corner. Read papers, all of this. And as I said in the beginning, you need to filter out the unimportant things. And I think I never even read a paper about any scheduler or something in the last 2 years or so, because I don't really care. I just use Adam W and cosine scheduler every time, and it works. It just works, and I don't want to spend time on to learn about some fancy new stuff, as long as it doesn't really stick to all problems. If it's super specific to some, I don't know, super large language models or so, it may be important there, but it's not important then for fine tuning some vision models, for example. So yeah, this is definitely something that you always need to do. So yeah, spend your time wisely on the things that you learn, or the things that you read, and try to make sense what is working on a larger amount of problems, and what is not working on a larger amount of problems, what is just super specific to this one. That really helps.
Thanks for that really insightful answer. Knowing where to dedicate your time, because I'm sure there's a lot of thought that goes into it for you as well while you're juggling so many things. So I'll take one audience question before going into a rapid fire round. Alex is asking, do you think that to be one of the top Kagglers, you have to be like always good at what you do? Was that true in your case? Because he's saying he assumes like top Kagglers were like best of their class, and then they graduated to like best on the leaderboard.
I don't know if where I was in the ranks of in my studies. I honestly don't know. So I think hard work is definitely the most important thing, and being very creative in the ideas is also another point, that you need to be open-minded, as I said multiple times. So it's just a mix of different things that you probably need to have. And I know lots of Kagglers. Not every Kaggler is approaching the problems the same way, and sometimes this one approach is much better than another approach. So I don't think there is a real answer to this, and it can be completely different in 2 years. Let's say if this zero-shot learning is getting traction at some point, it could become completely obsolete to even train new models. I don't know. I mean, we are just we're just thinking here.
Yeah.
So I wouldn't say that anything of this is set in stone, and the field is rapidly changing every day, week, year. And the skill set that you need to be competitive is also changing.
I'm sure Chat GPT-5 or GPT-5 will win a Kaggle competition, and they'll include
I
that
hope
in the
not, but
benchmarks.
who knows?
I'm on the side of GPT because I know it's looking at my data. So if you're watching GPT-5, I'm on your side. Jokes aside, I'll do a rapid fire round where I usually like to ask questions that if you can please answer in one word or one sentence, and these are absolutely random questions that I always end up asking. So I'll start by asking. I know we share a passion for motorcycles, or you used to at some point. So what's your favorite motorcycle of all time?
Exactly. I used to. I sold my motorbike.
I told you how sad I was to hear that.
Yeah. I was sad myself, but yeah, it's fair enough. I think at one point I would still love to ride a Ducati Panigale. That would be like a dream motorbike, I guess.
Panigale or M1000?
No, the Panigale.
Panigale. Okay.
Yeah.
I can't ride either of those in my country, so I
Why
only look
not?
at pictures.
Oh, but you're lacking the autobahn.
Yeah, I'll probably have to go to Autobahn to try
Yes.
that.
But I'm also a bit afraid of having the new maximum speed. If they
Okay.
really add it.
Favorite PyTorch framework, or if you just use PyTorch, or what framework do you use with it?
Yeah, I I only use PyTorch nowadays. In the early days, I also used TensorFlow, as it had also a much bigger market share, or share in the research. But nowadays, almost all the new implementations, all the new models, all the new ideas are implemented in PyTorch, so it makes it a lot easier to rapidly iterate through ideas, as you can just go to some repositories, try new stuff, and it's always available right out of the box, and you don't need to re-implement every paper that you find. So PyTorch all the way. Okay. I wouldn't mind anything coming up either. So if there is JAX or TensorFlow gaining traction because they add some super nice eager execution functionality, I don't know, maybe I'll switch over. I'm not
okay. Got it. Approach to writing code. Do you have a favorite ID? Do you have a favorite setup? Is it like Vim plus VS Code? Is it Jupyter Notebooks? What is it?
I almost can't say, but back in the days I was writing almost everything in Sublime Text. But recently, let's say 1 year ago, I switched to Visual Studio Code, and it changed a lot. At least for remote development, it's super easy to use.
With Copilot or without Copilot?
Depends. I mean, you can't use Copilot for classified things, but sometimes if it's just code that you are okay to share, obviously you can try it. But it's sometimes also way confusing what it does.
Makes sense. Last question, and Philip found this hard. Some other Kagglers found it easy. I think Beluga found it easy. If I don't know if you're a gamer, but favorite game of all time. I'm just guessing if you're a gamer.
Good guess. Yeah. Of all time, let's say Warcraft 3.
Warcraft 3. And how about a recent favorite, if any?
Yeah, I recently didn't play much, to be honest. So kind of stopped playing like 2-3 years ago. I don't know, maybe even longer. So from the recent games, I really don't have anything.
Okay. World of Warcraft 3 it is. I'll point everyone to your Kaggle profile one last time. So Pascal is ILU on Kaggle. Now you all know. And he's also, I don't think he's very active on LinkedIn, but if you want to find him there, you can just look him up. Otherwise, you'll always find him active in discussions. And if you ask him questions about his solution, usually anyone from Team Hydrogen shares very good insights. So I would suggest you find him there, or you can find him also in one of the future live streams on the channel or in a future video. So I'll wrap up with that. Pascal, thanks again for joining us and for all of your insights today.
Thanks a lot for inviting me and having me here. It was a super interesting discussion. Thanks.
Thanks everyone for watching. I'll end the live stream here.